right, we're going to work through a practice question from lesson 1.2 on your practice questions document. It's practice question number 2. Calculate the gravitational field strength on the surface of each of the following objects. First, we'll just work on A. I think if you can get A, then you can probably get B. So it's the same equation. So we have a mystery planet that has a mass of 6.50 times 10 to the 22 kilograms and a radius of 3.5 times 10 to the 7 meters. All right, so let's just draw this out. We have a planet and it's got some gravitational field strength, and if we're going to draw our field lines, remember gravitational field lines are always towards the object creating the gravitational field. All right, so on page 2 of your data booklet has all the formulas we're going to need for this section, or just this section, this lesson. And here's the one that we want. We're looking for the gravitational field strength, G. So little g is our gravitational field strength, and that's going to be equal to our big G, which is a constant, times the mass, all over the radius squared, or you can think of it as the distance from the center of the object to where you're testing it. And we're talking about the surface of the object. So if we're told the radius of the planet is this, then that's our distance to the surface of the planet. All right, so let's just see what we have. So we've got radius. They just told us that, and we just talked about it. So there's our radius in meters. Awesome, we're so lucky. Because if we want, we can double check, what does our radius need to be in? It needs to be in meters. So that's the first thing you want to make sure. If it's not in meters, you're going to need to do some conversions to get them to meters. And I do show you how to do a quick method in using your data booklet, or if you know how to do it, you can use whatever method you like. And then here's the mass of the object creating the gravitational field. So we're going to need that mass, and we'll just check its units as well. It is in kilograms, and that is the units that we need are kilograms. So we're set here. We don't have to do any conversions before we get everything into this formula. All right, so let's go down a line. I like to keep the equal signs underneath each other to keep things organized. That's a good habit to start working on if you don't already have that habit. So the gravitational, or big G, is a gravitational constant, which again, in your data booklet, you don't have to memorize that. It is 6.67 times 10 to the negative 11. And I am going to leave out the units so that we have a less cluttered area here. And then we're going to multiply it by our mass, m, which is from our equation above here. From our question, 6.50 times 10 to the negative, just to the 22. Good. All right, all over r squared. Here is our r. So 3.50 times 10 to the 7, and it's in meters, so we're all set to go. Now, what have I forgotten? Hopefully you see it. The r squared. This is the most common thing people forget when they're doing this formula. All right, now I prefer to do things in steps. If you want to plug everything into your calculator, that's totally up to you. But I like to actually square the number on the bottom first, partly so I remember to do it, and partly so I don't make an error in my calculation. So on my calculator, I'm going to type. If you want to type with me, I am using a graphing calculator. So 3.50, sure, why not? I'm going to hit the second function button, and the comma, or the EE button, is what I want to see. That's going to give me the times and the 10, and then I'm going to hit 7, and then I want to square the whole thing. So to square that whole thing, I'm going to hit x squared. All right, so you should have down below now 1.225, and you'll see it says e to the 15. Well, don't write e, write times 10 to the 15. If you start writing e's, then people think you don't know what you're talking about. So you want to make sure you put it back into scientific notation. And we don't need to worry about significant digits yet until the end, right? So let's write all our digits out. Then we're going to multiply the two top numbers together. So I am going to get you to pause the video right now, multiply those two numbers together as I do it. And you should get 4.3355 times 10 to the 12. Whoa, 10 to the 12. Okay, then you can divide these two numbers. And you should get our answer, yay, is 0.00353918. And we're going to look, we only have 3 significant digits in both of our numbers in our question. So we can only have 3 significant digits in our answer. So we're going to round that 3 up to a 4. So 0.0354, and that's what our answer here has as well. So you can play around putting these numbers into your calculator all as one big equation using brackets and see if you get to the same answer. This is a good test of your calculator use. And if you're not finding that you can get this to work, you need to get help, because this is going to be all over your assignment and obviously your quiz.